Hello guys, in this video we are going to discuss the solution of the problem left view of binary tree. So let us look at the problem statement. The problem statement says given a binary tree, return left view of it. Left view of a binary tree is a set of nodes visible when tree is visited from left side. The task is to complete the function left view, which accepts root of the tree as argument. If no left view is possible, return an empty tree. So for instance, if this is the tree which is given to us, the left view is 1, 2, 4 and 8. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say this is the binary tree which is given to us and we want to form the left view of binary tree. So how do we solve this problem? Well, the way we are going to solve this problem is using level order traversal. And while performing level order traversal, all we have to do is we have to append the first node of every level in our answer list. So what we are going to do is we are going to form our answer list for every level. So let us go to the first level. For the first level, what is the first node? Well, the first node is 1. We are going to push it into our answer. Similarly, when we go to the second level, the first node is 2. We are going to push it into our answer. Similarly for rest of the levels. So 4 and 8 will be pushed onto our answer and towards the end we will be returning answer. So that's the general idea behind solving this problem, folks. Now let us formalize this part, which is how do we append first node of every level in our answer list. So to tackle this, the first thing which we need to identify is this the beginning of new level? And if this is the beginning of our new level, then we are going to push the first element of the new level onto our answer. Now let us work with an example in order to understand how we will be able to answer these questions. So let us say this is the binary tree which is given to us, and as in level order traversal we are going to take a queue. So let us say this is the queue which is given to us, and we are going to push the root of the tree onto our queue. Apart from pushing root of the queue onto our queue, we are also going to push none, and this none indicates end of a level, which simply in turn tell us that the next node will be the first node of the next level. So let us use this. So as in level order traversal, we are going to pop the root of the tree. So we will pop an element from our queue. And since this is our first node, so what we are going to do is we are going to push this node onto our answer list. So let us say this is my answer list and this is a queue. And we are going to push the popped element into the answer list. Now we are going to check whether left and right child of 1 exist or not. If it exists, we are going to push it onto our queue. So since it exists, let us push it onto our queue. Now the next element which we are popping is a null element, which simply indicates that a level has end. Now since a level has end, we are going to push null into our queue. Please note, the null will be pushed only when the queue is not empty. If the queue is empty, we are not going to push null. So in this case, we have pushed a null, again indicating that a level has end. Now since we have encountered null over here, so what we are going to do is we are going to take a global variable, let us call that global variable as skip, and we are going to mark that global variable as false, indicating that the next element is something which we are not supposed to skip. Instead, we are going to push it onto our answer. So now the next element onto our queue is 2. We are going to pop this element from our queue, and then we are going to check this global variable which is a skip. Now since this global variable is false, which simply means we have to consume this element, so let us push it onto our answer list. And after consuming this element, we are going to mark this skip variable as true, indicating that now the subsequent element we want to skip. And as always, we will check whether left and right child of 2 exist. If it exists, we are going to push it onto our queue. So 4 and 5 will come to on our queue. Now the next element is 3, and since skip is equals to true, so we are not going to push it onto our queue. But still we are going to check whether the left and right child exists. Since it exists, we are going to place it onto our queue. Now the next element is none. Since we have encountered none, we are going to mark it as false. And since we have encountered none and the queue is not empty, we are going to push none onto our queue. Now the next element is 4, and since skip is equals to false, so let us push 4 onto our answer and check whether left and right child of 4 exist or not. Since it exists, we are going to push it onto our queue. And once we have consumed 4, we are going to update this flag to true. Now the next element is 5, and since skip is equals to true, so we are not going to push it onto our queue. And since left and right child does not exist, so nothing will be pushed onto our queue as well. And the same thing goes for 6 and 7. Now we are encountering a none. Since we have encountered none, we are going to mark it as false, and we are going to push none onto our. Now the next element is 8, and since this value is false, so we are going to push it onto our answer list, and then we are going to update it to true. Now the next element is none, so we are going to mark it as false, but since there isn't exist any element on the queue, so we are not going to push it onto our queue. And in this way, we have performed the level order traversal, and while performing the level order traversal, we have obtained the left view of our tree. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find the left view of a tree and root is given to us. So let us have an empty answer list, and we are going to check if root is not none. If this is an empty root, then we are just going to return answer. Otherwise, let us take a queue and initialize this queue with root. And as we have discussed, let's take an skip flag. An initial value of this skip flag is false. And also we are going to push none onto our queue. Now we will be iterating on queue while queue is not empty. And the first thing which we will be doing is we will pop an element from the queue, and let us check if root exists or not, or whether root is none. If root is not none, then let us check our skip flag. If we don't have to skip this root, then not skip will be true, and in such case all we have to do is answer.append root data. And once we have done this, let us mark our skip equals to true, which indicates that the subsequent element we want to skip. Otherwise, let us say if this is an empty root, then all we have to do is we have to check if queue is not empty. If queue is not empty, let us push none onto our queue, and let us mark skip equals to false. And finally, let us check if left and right child exist. If left and right child exist, let us push it onto our queue. And towards the end, all we have to do is we just have to return answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So for that, answer equals to an empty list, and if this is an empty tree, then we are returning answer. Otherwise, we are taking a queue, we are pushing root and none onto our queue, and then skip variable which is set to false. Then we are iterating on queue while queue is not empty. The first thing which we do is we pop an element from a queue, and then we check whether the element exists. If the element is not an empty element, then we check skip flag. If skip is set to false, then we push that element onto answer, and then we mark skip equals to true. Otherwise, if it is an empty element, then we check whether queue is not empty. If queue is not empty, then we push none onto our queue, and we mark skip equals to false. And towards the end, we check whether left and right child exist. If left or right child exists, then we push it onto our queue, and then we return answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at our C++ solution. So the C++ implementation is also the same, folks. We have our answer empty list, and we check whether it's an empty tree. If it is an empty tree, then we are returning an empty answer list. Otherwise, a queue is needed, and we push root and null onto our queue, and a Boolean type variable is skip equals to false. Then we iterate on queue while queue is not empty, and we pop an element from the queue, and we check whether that element is none or not. If that element is not null, then we check whether the skip flag is false. If the skip flag is false, then we push that element onto our answer list, and then we mark skip equals to true. If the element is an empty element, then we check whether queue is empty. If queue is not empty, then we push none onto our queue and we mark skip equals to false. And then we check whether left and right child of that root exists. If it exists, then we push left and right child onto our queue, and towards the end we return answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.